Deep learning is a subfield of machine learning that involves the use of artificial neural networks with many layers, hence the term deep. Deep learning has been particularly successful in areas such as computer vision, natural language processing, and speech recognition, and has enabled breakthroughs in areas such as image and speech recognition, language translation, and game playing. The basic idea behind deep learning is to use neural networks with many layers to automatically learn features and patterns in data, and to use that knowledge to make predictions or decisions about new data. The key advantage of deep learning is that it can learn features and patterns at multiple levels of abstraction, allowing it to capture complex relationships in data that may not be easily discernible using traditional machine learning techniques. Deep learning involves the use of many different types of neural networks, including 1. Convolutional neural networks, CNNs. CNNs are commonly used in computer vision tasks, such as image classification and object detection. CNNs use a series of convolutional layers to extract features from images, and then use fully connected layers to make predictions. 2. Recurrent neural networks, RNNs. RNNs are commonly used in natural language processing tasks, such as language translation and text generation. RNNs use a series of recurrent layers to process sequences of data, such as sentences or time series data. 3. Generative adversarial networks, GANs. GANs are used to generate new data that is similar to a given dataset, such as generating realistic images or text. GANs consist of two neural networks, a generator network that generates new data, and a discriminator network that evaluates the quality of the generated data. 4. Autoencoders. Autoencoders are used for unsupervised learning and dimensionality reduction tasks. Autoencoders consist of an encoder network that maps input data to a lower dimensional representation, and a decoder network that maps the lower dimensional representation back to the original input data. Deep learning has many practical applications, such as image and speech recognition, natural language processing, recommendation systems, and predictive analytics, to name just a few. As the amount of data continues to grow and computing power becomes more powerful, deep learning is becoming an increasingly important tool for solving complex real-world problems. Sure, here are some additional details about deep learning. 5. Transfer learning. Transfer learning is the process of using knowledge gained from one deep learning task to improve the performance of a model on a different task. Transfer learning has been particularly successful in areas such as computer vision, where pre-trained models can be fine-tuned on new datasets with relatively little data. 6. Reinforcement learning. Reinforcement learning is a subfield of deep learning that involves training an agent to interact with an environment in order to maximize a cumulative reward over time. Reinforcement learning has been particularly successful in areas such as game playing, robotics, and autonomous systems. 7. Explainability and interpretability. Explainability and interpretability are increasingly important topics in deep learning, as there is a growing need to understand how deep learning models are making decisions. Explainability and interpretability techniques can help data scientists to understand how their models are working, and can help stakeholders to trust and adopt deep learning solutions. 8. Deep learning frameworks. Deep learning frameworks are software libraries that provide tools for building, training, and deploying deep learning models. Examples of popular deep learning frameworks include TensorFlow, PyTorch, and Keras. 9. Hardware acceleration. Deep learning models can be computationally demanding, particularly when they involve large datasets and many layers. Hardware acceleration, such as the use of graphics processing units, GPUs, or field programmable gate arrays, FPGAs, can greatly speed up the training and inference of deep learning models. These are just a few more details about deep learning. As you can see, deep learning is a complex and rapidly evolving field, with many different techniques and subfields. However, at its core, deep learning is about using artificial neural networks with many layers to automatically learn features and patterns in data, and to use that knowledge to make predictions or decisions about new data. Deep learning has many practical applications across many different industries, and is a powerful tool for solving complex real-world problems.